Hello, today we're going to discuss 5.4 differentiation of exponential functions. The huge advantage of the natural base e is when you take the derivative of e to the x, you get e to the x itself. So we can use this formula to take the derivative of any function involving exponential functions. So let's differentiate the function f(x) equal to x squared times c to the x. So this is a product of two functions, x squared and e to the x. We need to use the product rule. So we get the x squared prime times e to the x plus x squared times e to the x prime. And then that becomes 2x e to the x plus x squared e to the x. And we can factor out e to the x and arrange the terms by the descending power of x to get x squared plus 2x times e to the x. Now, if the exponent is a function f, then we need to use the chain rule. So we get the derivative of e to the f of x equal to e to the f of x times f prime. Let's find the inflection points of the function fx equal to e to the negative x squared. To find the inflection points, we need to take the second derivative of the function and set equal to 0, solve for x. So let's take the first derivative by using the chain rule. So we get e to the negative x squared times negative x squared prime. So that becomes negative 2x times e to the negative x squared. Again, this is a product of two functions, negative 2x and e to the negative x squared. We need to use the product rule. So f double prime is equal to negative 2x prime e to the negative x squared plus negative 2x times e to the negative x squared prime. So we get the negative 2 e to the negative x squared plus negative 2x times e to the negative x squared times negative x squared prime. So this is a chain rule again. So that becomes negative 2 e to the negative x squared plus negative 2x e to the negative x squared times negative 2x. Now we can factor out the negative 2 e to the negative x squared to get 1 minus 2x squared and rewrite the whole thing as negative 2 times 1 minus 2x squared over e to the x squared. So set that equal to 0, we got the numerator to 0 and we get the equation 1 minus 2x squared equal to 0. And that gives us a solution of plus or minus square root of 1/2. Now let's apply the exponential function in economics. The monthly demand for a certain brand of table wines is given by the demand equation P equals 240 times 1 minus 3 over 3 plus e to negative 0.0005x, where P denotes the wholesale price per case in dollars, and X denotes the number of cases demanded. Question A, find the rate of change of the price per case when X equal to 1,000. Question B, what is the price per case when X equal to 1,000? So in question A, we need to take the derivative of P. So we do it step by step. When you take derivative of 1, you get 0. And then you can multiply 240 with negative 3 to get negative 720. So that becomes negative 720 over 3 plus e to the negative 0.0005x prime. Now we can rewrite this thing as negative 720 times 3 plus e to the negative 0.0005x to the negative 1 prime. And then use the power rule and the chain rule. So we get the negative 720 times negative 1 times 3 plus e to the negative 0.0005x to the negative 2 times 3 plus e to the negative 0.0005x prime. The derivative of 3 is 0, and the derivative of e to the negative 0.0005x is e to the negative 0.0005x times the derivative of negative 0.0005x according to the chain rule. All right, so we get 720 times 3 plus e to the negative 0.0005x to the negative 2 times 0 minus 0.0005 times e to the negative 0.0005x. And we can do a little simplification to get the negative 0.36 e to the negative 0.0005x times 3 plus e to the negative 0.0005x to the negative 2, and rewrite the whole thing as negative 0.36 times e to the negative 0.0005x over 3 plus e to the negative 0.0005x squared. So when x equal to 1,000, plug in 1,000 for x in the expression, we get negative 0.36 e to the negative 0.5 over 3 plus e to the negative 0.5 squared. And that will give us negative 0.0168. So that's question A. Question B, just plug in 1,000 for x in the demand function p. So we get 240 times 1 minus 3 over 3 plus e to the negative 0.0005 times 1,000. And we get 40.4 at the end. So you can see that the rate of change is negative and is small. So this is the end for today.